This video is going to be about finding the area of composite figures. And a composite figure is simply a group of figures that are connected together to make a larger figure. So you'll see by the end of this video, you should know how to break down a composite figure into several small shapes, find the area of each of those small shapes, and then add the areas of the small shapes to find the area of the composite figure or the composite shape. So let's go ahead and get into the first example. And the first example, we are going to look at the example 1. So we're going to break this down into different shapes. And right here we see a rectangle, we see another rectangle in the middle, and then a rectangle here on the side. So this rectangle right here has the dimensions 5 millimeters and 2 millimeters, the length and the width. So in order to find the area of a rectangle, we need to multiply 5 times 2. So we have 5 times 2 here, which that equals 10. So the area of this rectangle right here on the left side is 10. All right. Now let's take the one in the middle. So this rectangle, and I'm going to write it down here, it has the dimensions 2, and then as you can see, it shows the dimension from top to bottom as 1 millimeter. So the area of this one right here is 2 times 1, which equals 2. And then this one over here, it is, let's write a line right there so we can separate it. So this one is 2 by 5. So same thing, we can multiply 5 times 2 or 2 times 5. We'll get the same answer to find that area. Okay, so I have 3 rectangles. The first one has the area of 10. The middle one has the area of 2. And the one on the right side has an area of 10. So in order to find the area of this entire shape, I'm going to take 10 plus 2 plus 10, and that's going to give me 10 plus 2 is 12. 12 plus 10 equals 22 millimeters. So 22 millimeters is the area of example 1. Now, there's other ways you can do that one, but I would say do it like this. The main thing is making sure you find the area of each shape. Let's go on to the second one, and I'm going to get to that layer so that I can break down that one. That one is going to be actually, let's see, let's find the layer over here. All right, I think it's over here. Yep, that's the layer. All right, so on this one, this has several shapes. Now we can actually take these shapes and let's see how we want to break these shapes down. Well, I'm going to break it down like this. So let's say I have let's do this. Let me get my ruler to come up. Just a minute. All right, there it is. So I take this shape right here. You can do it top to bottom, side to side. It's up to you. And I'm going to draw a line there. I'm going to draw a line here. And then I'm going to draw another line here. So now I have several shapes in one. And you can do it from side to side. That's totally up to you. It's just all in how you want to do it. So let's look at this one. Now notice, remember the opposite sides, and this is where some of the rules come into play. So the opposite sides of a shape of a rectangle and a square are the same. So if this right here is 3 centimeters, then that means this side right here is 3 centimeters. Okay, so I have 3 centimeters here, and now if this entire thing if this entire side is 10 centimeters, then that means from here to here is 10 centimeters. So I noticed that this portion right here is 2 centimeters. This portion right here is 3 centimeters. So that means 10 minus 3 is 7, minus another 3 is 4, minus this 2 is 2. So that means this one has to be 2 centimeters. And just to recall what I'm saying by that is this side right here of this rectangle is 10. So that means this side right here of this rectangle is also going to be 10. So 2 plus 2 is 4, 4 plus 3 is 7, and 7 plus 3 is 10. So that means that this first rectangle has an area of 3 times 2, which equals 6. Okay, now we can do this one. It's like I say, in the eye of the beholder. I know this dimension is 2. I know that this dimension is 3. So I would say, so if this is 3 right here, notice if this is 3, then that means this is 3 right here. So I have 3 plus 3, which is 6, by 2. Okay, so the area of this one right here is 6 times 2. And just to make it clear where we're getting this 6 from, we have this right here, from here to here is 3 centimeters. And then remember, this length right here is 3 centimeters. So from here to here is another 3 centimeters. So that means that this green line is 3 centimeters there, and then 3 centimeters here, and 3 plus 3 is 6. So I have this rectangle is 6 centimeters by 2 centimeters, which means it's 18 centimeters. Okay, so I have 6 centimeters for the first one, 18 centimeters for the second one. Now let's do the third one. Well, we're going to do a different color for that one. Let's do blue again. Actually, no, let's do red. Let's do red. So here, I know that this is 3 centimeters across. Same thing here. So I have 3 centimeters. I have 3 centimeters here. So that's 3. I have another 3 right here because this is the same length as this. So 3 there, 3 there, and then this is another 3. So 3 plus 3 plus 3 is 9. So that means the area of this one is 9 times 3, which is 27 centimeters. Okay, and then for the last one, we have 3 across the top and 3 right there. So 3 times 3 equals 9. Now, to find the area of the composite figure, I need to take the area of all of the smaller figures. So the first one was 6 centimeters. So I have 6 centimeters plus 18 centimeters plus this one is 27 centimeters. And then this last one is 9 centimeters. And I'm going to add all of those up together. So 9 plus 7 is 16. 16 plus 8 is 24. 24 plus 6 is 30. Carry this 3. 3 plus 1 is 4. 4 plus 2 is 6. So 60 centimeters is the area of this entire composite figure. Now, I know that was a lot, so you may want to take this video and rewind it, pause it, run it back. But that's how you find the area of that one. Looking at the area of example 3. Example 3 is, let's see, let's find it. right here. Example 3, so I have a triangle up top and a rectangle on the bottom. Now, what I want to do is the area of a triangle is, so area of a triangle, I'm just going to put a shaped triangle right there, equals 1/2 base times height, or you can take base times height divided by 2. Well, the base of the triangle is right there, okay? Now, in order to find that little red line, the length of that, we know that this entire line from the left side of the rectangle all the way across is 12 because it tells you that the entire length is 12 there. Well, if I take this red line is equal to 12 minus 3 minus 3 because I have a length of 3 right here and a length of 3 right there. So that actually equals 6, okay? So the base of the triangle, so base equals 6, and then the height, the entire height, as you can see, is 8 centimeters. Well, from bottom to top is 8 centimeters, but then from the bottom to this red line is 4, so 8 minus 4 equals 4. So the height of the triangle equals 4. And these are both centimeters. So now in order to find the area of the triangle, then I have A equals 1/2 times 6, which is the base, times 4. And I put the dot. The dot still means multiplication. You can use X, but as we transition into the middle school level math, they use these dots or parentheses to show multiplication. So to find that area, I can say 1/2 times 6, which is 3. And then 3 times 4 is 12. Or I can say 6 times 4, which is 24. So 1/2 times 24. And half of 24 equals 12 centimeters. Now this is just for the triangle. Now I need to find the area of the rectangle. And the rectangle is length times width. Well, here is the width, which is 4, and then the length is across the bottom, which is 12. So I have 4 times 12, which is the area of the rectangle, which is 48. And so then now that's 48 centimeters. So now to find the composite area, I need to take 48 centimeters plus 12 centimeters, and I will get 60 centimeters for the area of the entire shape. So the answer to example 3 is 60 centimeters. And let's put some stuff around that to make it stick out. All right. So that's example 3. And the last and final example is example 4. Example 4, as you can see, we have a half circle or semicircle, as it's often called. And then we have a rectangle. So let's do the circle first. Now the area of a circle, so area of circle is equal to pi times r to the second power. Pi representing 3.14 and r is the radius. Now the radius is halfway across the distance of the circle. So, or technically the radius is the distance from the center to any point on the circle, which is half of the diameter. So the diameter goes all the way across the circle. So this radius would be half of 14, which is 7. So what we're going to do to find the area of the circle, we're going to use 3.14 for pi. Okay, so 3.14. Let me write that again so it looks a little neater. So 3.14. I keep writing the 1 first. I mean the 4 first. All right, 3.14. And then we're going to say times, so I can put parentheses. The radius is 7. to the second power. Now, we have to do 7 to the second power first. So this is 3.14. And 7 to the second power is the same thing as 7 times 7. So 7 times 7 equals 49. So this is 3.14 times 49. All right. And that's going to give us the area of the circle, but we need to do half of that. Okay, so in order to find the area of the semicircle, we have to say 1/2 times 3.14 times 49. Okay, so just so there's no confusion, we have to do the 3.14 times 7 to the second power is the area of the full circle. But we only have half of that circle, and so we need to take 3.14 times 49 and find half of that. So let's do 3.14 times 49 first. That gives us 153.86. Okay, so this is 1/2 times 153.86. You can round it to 153.9, and half of that is 76.9. So 76.9 is the area of just the semicircle up top. All right, so then now we want to find the area of the rectangle, which is a lot simpler. We have 10 as that length and 14 as that width. So 10 times 14 equals 140. Okay, so we have 140 down here, and we have, let's write it up here. So 76.9 up here. We're going to add those together, 140 plus 76.9. Let's make that 140 a decimal. All right, so we get 9, 6, and then 11, carry the 1, 21. So 216.9, and that would be millimeters, is the area of this composite figure right here. Okay, now some of them that you see may be a little different, but always remember you have to take what you know about the areas of, or take what you know about the properties of shapes. So for example, the opposite sides of a rectangle are congruent. The opposite sides of a square are congruent. All 4 sides of a square are congruent as well. And you have to use those properties to find the missing sides of some of these shapes in order to break them down. So it can be a little tedious, but at the same time, if you use those properties, it will show you or reveal to you mathematically the unknown lengths that you're looking for, and then you just take and apply the area formula for triangles, rectangles, squares, circles, parallelograms, and all the different shapes that you use. And once you find the area of each of the smaller shapes, you simply add those areas together to get the area of the composite shape.